Hello and welcome to Book Bites, a book club podcast for developers. Today we're talking about You Look Like a Thing and I Love You, How Artificial Intelligence Works and Why It's Making the World a Weirder Place by Janelle Shane. I'm Adam Garrett Harris.
I'm Jason Staten.
And I'm Megan Duclos.
Megan is new to the podcast and will hopefully be a regular co-host. We work together, and can you tell us a little bit about yourself?
Oh, sure. Where to start? I'm a software engineer at Pluralsight, just like Adam. We actually work on the same team. I've been coding for a couple of years now. I'm still pretty new to it, but I really like books a lot. So this is right up my alley.
That's why I wanted you on the show.
Yeah.
Welcome.
And cool. I'm super excited to have you. Yeah.
Thanks for having me.
So, the author, Janelle Shane, she writes about artificial intelligence on her blog called AI Weirdness, and how AI sometimes gets really weird and hilarious, or sometimes really unsettling, how it can get things wrong. And she's been featured in the New York Times and the Atlantic and all sorts of places, and wrote this book now kind of based off of that blog. So let's get into the book. What did y'all think overall?
Overall, I really liked it. I found it really interesting. Something I thought of tonight as I was finishing the book is it surprised me how AI is everywhere, but then also on the other side, it surprised me how limited it is. Because I really didn't know much about AI before reading the book, but a lot of things like that surprised me, and I found it really interesting.
Yeah, I definitely think she takes some of the mysterious parts of AI and kind of pulls off the covers a bit to see what's actually going on. And it's not done in a way that is dismissive or diminishing of it, but rather in a way of, yeah, like this promise was made that AI can accomplish this thing, but in fact that has some human assistance in it, or it only works in this super narrow case.
Yeah, that's kind of what the introduction talks about, is like, hey, is AI soon going to be everywhere? Well, on one hand, it already is. It's online, determining ads, suggesting videos. There's detecting social media bots, being social media bots. It's like approving candidates for resumes and approving loans, and it's a little bit in self-driving cars, and even in some like not so self-driving cars, and it's in smartphones. But then also, no, on the other hand, it's not flawless. It's way overhyped. It can't do everything we think it can for lots of different reasons.
Yeah, and it's also like not very good at some of the things that you just said it does. Like,
right. It probably shouldn't be used for some of those things.
Yeah.
So like at the beginning, she has 5 principles of AI weirdness. Like the danger of AI is not that it's too smart, but that it's not smart enough. The second one is AI has approximate brain power of a worm. So, yeah. And AI doesn't really understand the problem you want it to solve. But AI will do exactly what you tell it to do, or at least try its very best. And it will always take the path of least resistance.
Yeah, it made me think of water, or where water always takes the simplest path that it can, or like the most downward approach that it can, until it eventually runs into something that it has to go around.
Yeah, there's an episode of The Simpsons where Homer goes off and runs away. He leaves home, and Marge finds him, and he's like, "How'd you find me?" And she's like, "I just left house and started going downhill."
That sounds very AI like.
Yeah.
If the criteria is to like make as much distance as possible, like, I mean, certainly downhill is what you're going to take.
Yeah, I like the examples of, it was trying to teach robots to walk. So the goal was make it to this point. You start at point A and end up at point B. And what it would usually do is grow really tall and then just fall over.
Yeah, that was pretty funny. Like, I got there. I did it.
Yep.
Yeah. So what did you think about the definition where she kind of defines both rules-based programming compared to machine learning?
Yeah, I mean, rules-based learning involves listing out every single step, whereas machine learning kind of just figures out the rules for itself by trial and error.
I thought it was helpful that she compared it to rules-based programming, because that's what I'm most familiar with. And so seeing how they were different from each other helped understand better what it is.
I think for me as a developer that is very much like rules oriented, like I mean, imperative type programming, it's almost a little bit uncomfortable knowing that like you're creating this thing that's not exactly right, but instead like it's getting to some probability of being correct.
Right. Well, I mean, in some of the problems you give AI, there is no one right answer.
Mm-hmm.
Like how can you make an algorithm to generate cat names, and how would you write unit tests for that? Like, what is the correct possible answer? Like the definitive list of possible correct answers. There isn't such a thing.
Yeah, and that's kind of the whole point of getting an AI to do that for you, is that you don't have to think of that list.
Yeah. Yeah, it said it's more like teaching a child than it is programming a computer. You just let the AI figure it out, and it comes up with its own rules, and sometimes its rules are bad. It talks about like different ways to detect a bad rule. Not that you can really see what the rules are. It's really hard to look into an AI and see what it's thinking.
Yeah, that was one of the things that I did like that she called out, where Google had its dream project where it kind of made really funky artwork, and part of that was going and picking at the nodes within the neural network that had been created and amplifying how important they were to see like what does this thing actually represent, in order to say, oh well, actually we need to not have this or decrease its importance in the realm.
We want to talk about the title of the book and where
yes.
it came from.
Yes, so like I originally thought the title was the idea that the AI it looks at things and it's like I like it or I don't like it. But you want to explain?
Yeah. So she's talking about how let me see here. She's talking about like teaching it like it's an impressionable child. She's kind of knowing that the AI is going to start with a blank slate. And she starts training the AI to produce pickup lines, and that was one of the pickup lines that it came up with. And a lot of them were really weird. Like some of the other ones were, "You must be a tringle because you're the only thing here." And
a triangle?
no, a tringle. There's no A in that word.
Oh, okay.
Which makes it even funnier. I don't know.
You're so human, Adam, overlooking that.
Yeah. And these were like the best ones that she curated.
Yeah,
and
there
the
were
funniest.
others that were a lot worse.
That was a common theme within the book, I felt as well, was that human intervention or like working alongside the AI is definitely a critical component of being able to pick out like what are some of the top ones from this generated output that came to.
Yeah. Yeah, and she also talks about things in this book that she is calling AI and things she's not calling AI. One thing she is calling AI is machine learning algorithms, and that's typically what she's talking about in this book, I think. And then there's deep learning, neural networks, recurrent neural networks, whatever that is, Markov chains, random forests, genetic algorithms, lots of other stuff, predictive text. But the things that aren't AI are stuff from science fiction, rules-based programming, humans in robot costumes, or, humans hired to pretend to be AIs, which actually happens a lot.
I believe that one of those is the history of where the name of Amazon's Mechanical Turk came from. Was that historically there was a person who claimed to have invented a machine that can play chess better than any human can. And in fact, it was just a box that had a human in it that played chess really well. I'm going to go and find the Wikipedia for that one.
Okay. And that's where Amazon Turk came from?
Mechanical Turk.
Which is Mechanical Turk. She mentions it in this book, actually. It's humans that do like a bunch of really simple tasks that you can hire out to. It's almost like a humans as a service. And she uses it to maybe gather data or I don't know, things like that. Things where you want humans. But But then one of the problems with it is that the humans sometimes, because they're not paid very well, and you want to do as fast as possible to get paid, they'll use bots to do the task, which kind of defeats the purpose.
So you have to do the Turing test against them. The Turing test being that theory by Alan Turing that if something can fool 1/3 of humans into thinking that it itself is a human, then it passes that test. But Janelle actually...
That's a pretty low bar to pass.
1/3 of humans.
Yeah, it's like the I can't remember the name for it. It's the test in movies. I'll remember it. You can delete this part.
I think she mentions the Turing test being in movies, like I can't even think of it now. Ex Machina. But yeah, anyway,
that's not what I'm thinking of. Oh, the Bechdel test. That's what I'm thinking of. It's like a low bar to pass. The Bechdel-Wallace test is like a measure of representation of women in fiction, so like movies and books and stuff. Where basically like the requirements for that are that it has to have at least 2 women who talk to each other about something other than a man, and those 2 women must be named characters. Which you would be surprised how many movies don't pass that. But I digress.
Wow. I was trying to think if even Pride and Prejudice passes that test, because they talk about men a lot, even though there's a lot of women characters.
Yeah.
With Mechanical Turk, they have to, in order to ensure humans are doing it, give them some other random tasks just to make sure they're paying attention.
Yeah, I've actually done some Mechanical Turk, or Turking, I guess, as they call it in the past, just to try it out. And you are offered up like an activity that you do, and maybe it is looking at an image and clicking on all of the cows in it. Or I saw one that I thought was actually a pretty awesome idea, was for races, when there's like a big race that has hundreds of people in it, going and picking out which pictures belong to which racer is a challenging job. And while machine learning can definitely do a lot, there's also a need for like human training on some of that as well, or like training those models in order to do it. So a lot of times that can actually wind up going through a set of Mechanical Turk workers to say, oh yes, this is this bib number and this is this bib number.
Okay, so chapter 2 talks about AI is everywhere, but where is it exactly? And one of the weirdest examples was that it runs a cockroach farm. I don't remember exactly why they had a cockroach farm.
I don't remember the reason for it, but
that's like a recurring theme throughout this book, as she uses that as an example.
Yeah, as an algorithm to go and like optimally raise a set of cockroaches.
Okay, so they would actually grind up the cockroaches for some Chinese medicine.
Okay.
But it said actually that's a good job for an AI, because it has, for one thing, it has really quick feedback loop, because cockroaches don't live for very long before they reproduce again.
And given else? You give it only like a narrow set of controls too. Like, I mean, that's the important thing. She mentions that, I mean, if it were able to go and like crank the heat up in one room so much that it wound up killing the whole room in order to, I don't know, give success to another room or something, like that could also be a way for the AI to succeed, but with having like guardrails in place in order to stop that. It's probably something you need to remember too.
Yeah.
And it moves on as well to get into self-driving cars, because that is one of the kind of big hyped AI cases that exist in today's modern world as well.
Right. And I thought we were really, really close to getting AI without having to have a human sit in the seat.
But we're really not that close.
After this, I'm not hopeful to see that in my lifetime.
Yeah, that's kind of disappointing, but oh well.
But I do expect to see a high level of automation. I mean, we're already seeing lane assist and smart cruise control, and it can go for long stretches on boring highway roads without needing any assistance. If there's anything unusual, you can take over. But it did say one problem is that humans are not good at taking over quickly when they're used to not paying attention. And I can imagine that being really boring, just sitting there waiting.
Yeah. It can be bad enough taking a long road trip with just cruise control on sometimes, where you think, where did that last half hour go?
Yeah.
Yep.
And she does also mention that, I mean, some of the options to get us more automation wind up looking like existing public transit options, where you have, say, like a caravan approach where like one car happened to be actually driving with human in it, and then the rest of them are like tailing it, like in lockstep, and or having like specific paths that are designed for AI type driving, kind of like a like
or maybe tunnels.
Yeah, or like a tunnel. But at that point, we also have means of transit that go through tunnels called subways, and or designated paths that are rails that trains can't steer off of. So
right. Yeah. I mean, it talked about there's a lot of ways that you could trick a self-driving car. You could just put up a stop sign, or like paint a tunnel on a wall. And then like how is it gonna know to recognize emus
when it's never seen an emu in its training set?
Yeah. Or what if the zombie apocalypse happens and it doesn't know that it's okay to run over the zombies? They're not actually pedestrian. There's just no way to train them on that. Like, the world does change. And a more serious example is someone was like, hey, let's make a AI that recognizes cars. Oh, wait, there already is one. Oh, wait, no, it's trained on data from like the 1980s, so it doesn't recognize any modern cars. I thought it was going to say it was trained on normal cars, and then the Cybertruck came out and it can't recognize that.
Wow. That wouldn't really, I don't know. That wouldn't be as common of an issue.
Yeah.
Anyway.
But I mean, I barely recognize it as a car.
I think you're right.
So let's move on to how they learn.
I liked this chapter.
Chapter 3 had a lot.
And the magic sandwich hole.
You want to describe that?
Sure. So she's trying to illustrate how machine learning works. And she says, hypothetically, let's say we've discovered a magic hole in the ground that produces random sandwiches every few seconds, which that's very hypothetical. But so the problem with that is that the sandwiches are very, very random. So ingredients could include jam, ice cubes, old socks, literally anything could be on the sandwich. And so we would have to sit and sort through all the bad sandwiches to find any good sandwiches, which is really tedious work. So she's talking about hypothetically training an AI to do that work for us. And I thought it was a really great way to illustrate how it works, and what an AI would do with that. And tell it like a cheese and chicken sandwich is good, but like if you add mud to that sandwich, it's definitely a no. But then she goes through.
Yeah, but it's like, how does it know if it's the mud that's bad or if it's the chicken that's bad?
Yeah. Or if it's just specifically the combination of mud and chicken, like maybe mud is good with something else.
Yeah. Mud and peanut butter.
Like in peanut butter. But she goes through like all these different ways that an AI could get really confused and think that like eggshells and peanut butter is a good sandwich, but like peanut butter and marshmallow is bad. She gave the fluffernutter example.
I'm gonna have to try fluffernutter. Yeah, I don't know. It might be too much marshmallow.
I don't really like marshmallow, so I can pass on that one.
You can always swap for banana.
But
oh yeah,
I do banana all the time.
Yeah, I think she talks about like one problem could be that so many bad sandwiches pop out compared to some that are actually good that it just takes a shortcut and just always assumes it's bad.
Yeah, I was just about to say that. It's like, okay, you don't like any sandwiches. We just won't approve of any of the sandwiches. Which is just illustrating how an AI will take the path of least resistance, where it's like, I'm just not even going to try anymore because 99% of the sandwiches I think are good, you say are bad, so I give up, basically.
Yeah.
I'll still be 99% accurate if I say all the sandwiches are bad.
I think this section does a good job of showing kind of the diagram that an AI produces, where it has all of these inputs and it does it's just a bunch of numbers, and it does some sort of calculation on them, and there may be like several layers of that happen before it comes to the final output.
Yeah, and that those layers are necessary to deal with combinations. Right? Like if you have a single layer of nodes to handle input, then you get simple attribution of peanut butter good, mud bad, and that's kind of the extent of calculation you have. Whereas like the second layer can go and handle the things like the combinations, or that mud is a deal breaker and it always makes everything fail. Like if you have mud on any sandwich, like do not pass. And yeah, I don't remember what it's like the hidden layer, I believe that is called.
I don't know.
I do like as well that it goes on to describe some of the other algorithms as well, like talking about what they are and like what role that they can wind up playing. So like Markov chains, Megan, you had mentioned predictive text on a phone. Like Markov chains are a good candidate for that, in that they are really lightweight to go and create, and don't need a lot of processing power or storage. And so for typing on your phone, just being able to say like, here's a good possibility of next 3 words, but overall what they generate is not super high quality, or they can get stuck in things like a loop, like under the sea, under the sea, under the sea.
Yeah, and because they have really short memories, like they'll usually only have a couple of words in memory of the last 3 words that they suggested, or the last 3 words that were typed in. So only having that much context doesn't give them the full story.
As opposed to recurrent neural networks that look back hundreds of words or longer, so they would be able to get out of the under the sea loop that Jason was talking about. So I think she had a Markov chain here that was trained on Disney song data. Yeah. So a good example of this is just on your phone, and you start typing in a text message and then just hit the center word suggestion. And I've seen people do this where you just tap the center word and see what comes out. And that can be kind of funny. And it learns based on what you've typed into your phone in the past. So everyone's will be different, even if you start with the same words.
Which is why you can get haunted by a typo, or sometimes keyboards will store a number that you put in one time and always offer you that number.
A number.
Yeah.
Another example is a random forest algorithm, which to me kind of just looks like a flow chart of like a decision tree.
I mean, that's actually what she refers to it as, is a decision tree. But it's a bunch of kind of shallow decision trees kind of all put together to come to a conclusion, though.
Yeah.
And evolutionary algorithms, those are one that I feel like I've seen examples of online, where they have a generated course where it's so they have like a car that's trying to go across a course that was created that has maybe hills and valleys in it, and sometimes it has to jump a gap or something, and the algorithm is able to go and try like different wheel sizes for the car, or different weight distributions for it, in order to find like an ideal one. And the ideal one is the one that makes it the furthest on the map. And I'm gonna have to go and search for that, because it's kind of a cool way of seeing like the progression of the algorithm, where it starts off pretty terrible because it's just randomly guessing at what would be a car to use, and based on how it succeeds, the algorithm says, okay, this should move on to the next generation, and some attributes from this thing should be taken, or this one failed completely and it should die and not contribute its genes to the next pool.
Right, yeah. And the example in the book was you've got a hallway that splits into 2 different hallways, and the algorithm has to design a robot that will make people go down the right hallway, not the left hallway.
I loved this one.
And they can change the arm size or the foot size. And originally, like, they might just fall over because they made one leg too long. And then at some point, one falls over and it slightly blocks the left side.
And then at another point, it starts killing humans.
Yeah. No, I think at one point before it starts killing them, it just starts like yelling annoying things, and so the humans just walk around it to the other side.
Yeah.
and then eventually, let's see, if it starts killing humans, it wins, right? No humans went down
No,
the
because
left
then,
hallway.
yeah,
So you have to
so
change the
it
goal.
does win. Yeah, so it does win, and then they go in and say, okay, you can't kill humans now.
It changed the goal. It changed the goal where humans go down the right side instead of the goal being no humans go down the left side.
Yeah.
And then eventually it just makes a robot so big that it's like basically a wall.
And the picture for it is awesome. It says, "Yes, we have evolved a door." And it finally covers generative adversarial networks, which I thought this one was pretty awesome to learn about. I feel like I've seen the GAN abbreviation a handful of times and didn't know what it was or like what it stood for. And so to kind of hear the description of it helped me out a lot. So basically you have two machine learning algorithms working, against each other, or like you have two algorithms working to go, one doing generation and the other one is attempting to depict like was it generated or not. And
so it's a generator and a
yes,
discriminator.
And it is commonly used for like generation of images. So there is the website of like thispersondoesnotexist.com or something like that, where they you can go there and see all sorts of faces that are generated that are not real people, and they are quite convincing as long as you look at the faces. If you look at the edges, though, they can get a little bit scary, or a lot of times people are missing ears and stuff, or they're mismatched.
I'm looking right now. They are creepy good. I mean, not creepy. They're just good.
Yeah, like you could certainly use one in a smaller place too and be fooling. Like think like a Twitter avatar or something like that. You have like an unlimited pool to generate fake avatars for Twitter.
Yeah, and this was only just introduced in 2014 as a technique. And what I thought was really interesting about this is that the generator is you have to give it some sort of image to turn into the thing that it's trying to create. So you can't just say make a picture of a horse. You give it a picture of random noise, and then it turns that picture into a horse. And so that kind of made me think that it sounds like a pure function. Like given this exact image of white noise or random noise, it will produce the same image every time. Did you get the same feeling?
I guess I don't know. I didn't think too hard specifically on that front, but yeah, I'll have to reread that specific part.
Yeah, it's got an image on the bottom of 103 where it has a picture of like just some dots, and then it turns it into it kind of moves those dots around into a whole.
Okay, yeah, I see that depiction that you're talking about.
And so, what's really interesting about this is that it's much better to have a discriminator AI than it is to have a human, because at the beginning, the generator and the discriminator are both equally bad at their jobs. So the generator is terrible at generating pictures of horses. The discriminator is terrible at telling whether or not it's a horse. It can't tell the difference between a real horse and a bunch of garbage. And that's good because a human would just be like, no, 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 no. But this discriminator is really bad. So yeah, it's going to say yes sometimes. And then the generator can kind of work with that and get better and better.
Yeah. And she says that it, in a way, is using the generator and discriminator to perform a Turing test in which it's both the judge and contestant. So then, like, over time, by the time the training is over, it's generating horses that would fool a human judge as well. So, like, they both get to get better together.
Yeah.
And while it is impressive in what it does, there are also many ways that AI can go terribly wrong as well. And Janelle gets into that in the kind of next few chapters.
Yeah. I like in chapter 4, it gives a lot of reasons why the AI may not be good or may not be good at that certain problem. Like if the problem is too broad, the AIs are really good at very narrow tasks, which is another reason why self-driving cars is maybe not a good problem. It's very broad.
Yeah, and it's like constantly changing.
Yeah. Also, if you don't have enough data, it needs a lot a lot of data to train on.
And also bad data. So even if you can get lots of data, if you give it data that is of poor quality, and I mean sometimes that can be hard to distinguish even as a human, then that can be a case for failure as well. She gave the example of determining skin conditions and teaching an AI that, where it turned out that all of their training data that showed a picture of a tumor also had a ruler in it. Therefore, the AI learned that if it sees a ruler, then it's a tumor. And so it was a or a ruler detector.
It's so much easier to detect a ruler. Yeah, it's a ruler detector.
Which kind of reminds me, I don't know if either of you have watched Silicon Valley.
No.
But there is an episode where one of them creates some kind of machine learning thing.
Hot dog, not hot dog?
To tell if there's a picture of a hot dog. Yeah, hot dog or not a hot dog. And like there's miscommunication where like a bunch of these other engineers thought that he had created an algorithm that could just like recognize anything in a picture, but it was literally just determining whether the picture had a hot dog or not. And yeah, then there's other storylines that I won't get into right now, but yeah, that's what that
yeah, and there's also time wasting data. So I love the example of some researchers made an AI that generates images of cats, and then they notice like these blocky text-like markings on the images, and it turns out a lot of the cat images they gotten from the internet had meme text on them at the top and the bottom. So it was trying to not only generate the cats but also how to put text on it, and it shows some examples. It looks like words, but it's illegible.
That is one thing I've heard from some data scientists that I've talked to, is that like grooming the data is such a critical part and like such a major portion of that position before actually putting it through the algorithm, because I mean it is still like the classic garbage in, garbage out that you can wind up with.
Mm-hmm. Yeah, and then there's over and underrepresented data, kind of like what we mentioned with the sandwiches. If there's too many bad sandwiches and not enough examples of good sandwiches, we just take a shortcut and say all sandwiches are bad. And then there's a common thing in AI where AIs will often see giraffes everywhere. And I love this because people are more likely to photograph a giraffe than a plain landscape. So there's way more images of giraffes exist than is representative of the real world. And then other examples of female scientists being underrepresented on Wikipedia. It gives an example of Donna Strickland didn't get a Wikipedia entry until she won the Nobel Prize in Physics.
That is one of the things too, is just general bias that winds up coming through in the algorithms, simply because or I guess not in the algorithm, but like in the calculated result, simply from the data that's fed to it. Even if we as humans attempt to circumvent that bias by saying, well, I mean, we're not putting gender or race into the system, but there are ways that the algorithm, I mean, finds patterns that are like, oh, well, this person lives in this specific area, or has like this specific name or something like that, as a proxy way of determining that same thing.
Another thing in this chapter that I found really interesting was talking about a problem with AI called unintentional memorization, where she basically gives an example from 2017. Researchers from Google Brain showed that a standard machine learning language translation algorithm could memorize short sequences of numbers like credit card numbers or social security numbers, even if they just appear like 4 times in a data set of 100,000 data sets. So they would like, somehow the AI would just memorize it and just spit out a social security number or a bank number or something like that.
Yeah, and then if you can trick that AI into spitting that back out, then it's leaked information, sensitive information.
Yeah.
It's really
Yeah,
bad.
it can be a huge security vulnerability that can cause a lot of problems.
In chapter 5, it talks about overfitting. And overfitting is when an AI is trained for a very particular set of circumstances, but not for the variety of situations that it might actually encounter that you want it to work. So an example that's not actually AI, but with training animals. And she said there's a lot of similarities between training AIs and training animals. The Soviets tried training dogs to carry bombs and run underneath German tanks to blow up their tanks. But there were several problems with that. The Soviets, their tanks were not moving during the training because they wanted to save money on fuel. And so then the dogs would get scared around moving tanks. And also the German tanks smelled different. They ran on gasoline instead of diesel. And so often the dogs would end up running back underneath towards or underneath the Soviet tanks, which is really bad. And also really sad that they tried to use dogs for that.
Yeah, and I would say that because AI does have its shortcomings, and in these things, like that's where like the human intervention is necessary, and like um, and a lot of times why uh, AI products that exist are ones that fall back to a human when they can't recognize a scenario or can't handle a scenario. So like in a self-driving car, I mean, like if you're driving a Tesla, like it always expects the human to be there to take control, and it will start chiming at you and yelling at you if it's starting to have a problem, and making sure that your hand is also on the steering wheel as well every so often to make sure that, I mean, you're doing your human role. Or like a chatbot, it
Yeah.
will go back to a human if you start asking it things that are kind of nonsensical, and the AI can't distinguish what you're trying to say there.
Yeah, with the chatbots, it said later on, it said one problem with that is that it inflates people's expectations of what AI can do. If they don't know whether or not they're talking to a human or an AI, they may think AIs are really good. Secondly, they may be mean to humans when they don't mean to be because they think they're talking to a bot. And then thirdly, they may reveal sensitive information because they think they're just talking to a computer.
It's one of those things that made me think of I think it was a presentation Google made last year where they showed off using an AI to go and book a haircut, I believe it was, where
I think it was booking a reservation at a restaurant. Oh, and a
yeah,
haircut, yeah.
and like why while like I feel like that could work in a narrow situation, I could also feel it or like see it falling short with a, I don't know, kind of a basic question that maybe it's not trained for, of like, I don't know, do you have a gluten allergy or
Yeah.
something?
I was surprised with that example, not only how lifelike those AI's voices sounded, but they gave examples where they had unexpected questions and unexpected answers. Because with the haircut, it they asked like what kind of haircut or something, and it actually responded to that. And then with booking the restaurant, the person had a thick accent and had a hard time understanding what the person was asking, and or not the person, but what the AI was asking, and then it had to repeat itself, and it turns out they don't take reservations, and so it was able to handle that as well.
Yeah, I mean, it definitely is an impressive thing. Like, I mean, and would be awesome for some particular cases. I I
I think a major problem with this is going to be that small businesses might get inundated with calls from AIs, which could be super annoying. They might get more phone calls than normal. Basically, they would be penalized if they don't have online ordering or some sort of automated way to do it without AI.
So what you just need to do is these small businesses also need to get AI on their end answering the phone first. And then as
Yeah,
soon as that happens, like
right.
there's like a high frequency sound that denotes, oh, this is actually an AI that this AI is talking to. And then it just sounds like a modem.
Yeah.
That sounds great. But then no one will ever have to work customer service again.
Wait, wasn't there some sort of example in this book about AI? Oh, with voice recognition AIs, you could trick it with some sort of white noise that humans would just think is white noise, but then the AI thinks the person saying something completely different.
Yes. Yeah, I remember that.
It's basically the same idea as putting like a little square of white noise on a photograph, and then the AI thinks the photo is something else.
That was
that was in chapter 8.
yeah.
It's an adversarial attack. So that's known as a rainbow of static. And another way of tricking an image recognition software is you take one image and then you start slowly overlaying that image with one pixel at a time from another image, and eventually the AI thinks that it's seeing something else that a human wouldn't see. You just don't know like which pixels the AI is going to think is important.
Yeah.
Mm-hmm.
Although, like, thankfully now it's said there are ways of an AI pointing out which pixels it used to determine, so it can kind of highlight those, and it's not always what you would expect. I think, like with pictures of fish, a certain kind of fish, most of the pictures were of a human holding the fish. So the way I was recognizing it is human fingers on a green background.
I guess on one other note of humans and AI coming together too, is creativity, like creating art. And that is something that I was impressed with by a service that is called generative.fm. And that is a website that you can use similar to Spotify or like other music websites, where you can pick the type of music that you want, and then it will play that music and it will do it locally. So like the sound itself exists on your machine locally, but it is all generated from your machine. So it's not like it's streamed from somewhere or pre-recorded, but instead just on the fly, just keeps playing. As long as you choose to listen, it will keep generating more and more music.
Huh, that's cool.
They have a lot of ambient type stuff, so if you just need something in the background to listen to while coding, it's a good choice there.
Yeah, I see a lot of electronic. There's some piano, saxophone, guitar. It's cool. Another thing I thought was interesting that we haven't talked about yet is the idea of using multiple AIs to do one task, because AIs are best when they focus on one task, and if you try to teach them something else, they'll forget the first thing. So one example is an AI to play Doom, and there's actually 3 different AIs. So one is the vision. So it's like, I have detected various things. And then one of them is the memory. And it says, I predict the fireball will continue to get bigger. And then one is actually the controller. And it's like, dodge left.
Yeah, that was pretty cool.
So the future of AI might be more like that, like a swarm of many different AIs working together, each one focusing on a very small subtask.
Did either of you have a favorite chapter?
I have a favorite funny part.
Okay.
I like in chapter 1, she's having it make knock knock jokes.
Yeah.
And she kind of just goes from the beginning of how bad it is at first. Like at first it's like K space K space K space 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 K K K K K, because probably knock knock jokes have a lot of K's in them. and then it's just kind of gibberish, and it's doing some new lines and some question marks here and there, and then eventually it's like walk 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 walk. and then eventually it's like knock knock, who's there? Ian. At or who? Ain who? And who? And a who? I up who? I rada who? And then finally it kind of starts figuring out the formula. And I like, knock knock, who's there? A cow with no lips. A cow with no lips who? A cow with no lips says ooh ooh ooh.
Yeah.
And then it thinks the
best
cow with no lips is
ever.
like the best joke ever. So it keeps doing that one.
That was actually my note. This is my favorite part. I listened to the audiobook on my initial reading of it, and XZ Sands does it in like a robotic voice to do all of the AI pieces in it, and it is really good. Like I enjoyed listening to that part of it, because just gay K K K K O K, just yeah. And
wow, Does the audiobook read all of the dialogue of the pictures?
There are a few places where it says check out the PDF to go and see this thing. So it doesn't necessarily get all of them. So you do miss out on that. You miss out on some really nice illustrations. So the book itself is also worth going through. But I do think the audiobook did a nice depiction of the AI and giving it a voice.
Yeah, cool. Yeah, I didn't think this would make a very good audiobook, but overall it was okay. It was good.
Now I'm wishing I had listened to it because I find it so hard to find the time to sit down and read a book physically. That was hard for me to finish it in time. But I would have finished it weeks ago if I had just listened to it.
Yeah. I don't know how you take notes though when you're doing an audiobook.
Oh, I don't.
Right.
Sometimes I'll stop and pause and open up my notes app and throw something into there. Like if something really stands out to me.
I mostly just hope I...
All right. Any final thoughts?
So I thought it was a great spread of what the AI world looks like right now, and kind of is takes away the smoke and mirrors and shows more of what's going on with AI, but it does it at a level that I feel like I would be definitely apt to recommend to somebody who is less technical, that's not a programmer perhaps, and they could still get a ton of value out of this. So I really enjoyed it on that aspect.
Yeah, I really enjoyed it. It's very, very fun read, and it has a lot of technical things in there if you want to dig into it, but it doesn't get too technical. For instance, I like how it has kind of like vocabulary words in bold, but it doesn't give a technical definition. It just kind of gives you a feel for what the word means with a lot of examples. And so I really like that. And it can just be a quick, fun read, and it gives you, it can kind of calm your fears about AI, help you understand AI, where to expect it. And if you want to dig into it more, then I think this is a great jumping off place.
Yeah, I agree too. I think it's a really good intro to AI and machine learning. I didn't really know much about it before reading it, and I learned a lot. But it wasn't too overwhelming. It was really funny. And I think it's funny, Adam, that you mentioned it'll help calm your fears, because this is kind of silly, but I at a really young age I watched some movie about a robot that went turned evil or something, and it scared me so much that I have this weird irrational fear of robots taking over the world. Which you're supposed to laugh at that. That's not
this book does talk about unfortunate murder bots.
Yeah, so it's within the realm of possibility.
Yeah.
But this kind of helped me realize that AI as it is right now is just not smart enough for that yet. Yeah. Although a lot of them just kind of end up resorting to that one in the hallway. So I don't know, maybe my fear is not irrational and it's fine.
Well, I mean, it says, I think this is a key idea. For the foreseeable future, the danger will not be that AI is too smart, but that it's not smart enough.
Yeah.
And another really great quote from the end is, there's every reason to be optimistic about AI and every reason to be cautious. It all depends on how we use it. That's also great. I cannot stop looking at thispersondoesnotexist.com.
If you do get tired of it, going to Janelle's blog, aiweirdness.com, is also, it's some good reads.
It's a good laugh.
The Valentine hearts.
Yeah, and I love how she takes the things that the AI generates and actually puts them on. She's generating the Valentine's hearts and putting them actually on pictures of the Valentine heart candy, or taking recipes and putting them on recipe cards.
Yeah, it just makes it even funnier.
Yes. All right. Well, thank you so much for listening. You can find me on Twitter at Agarhar, AGARRHARR. Jason, where can people find you online?
Sometimes on Twitter at StatenJason.
And Megan, what about you?
I don't really tweet that much, but I am on Instagram.
And you can follow the show on Twitter at BookBitesFM, and you can find the show notes and transcript for the episode, as always, at orbit.fm.
See ya.
Bye.
Bye.